Hello and welcome. My name is Adam Cernoso with SoCal Tech Academy. We are a adult vocational school teaching people how to code along with other technological focused courses such as Cisco, CCNA, CompTIA Plus, CompTIA Network Plus. And today I'm going to go over Insertion Sort in JavaScript. And it's going to be one of the easier sorting algorithms that you learn. To get started, I'll show you guys that I have created a function, rand list gen, which generates a random list of a certain length with a upper bound and lower bound. Those are the parameters. So if I call this, it'll return to me a list of 10. The lower bound of 100, upper bound, lower bound of negative 100, upper bound of 100, lower bound of negative 100. And if I run this, you can see that all my numbers are between 100 and negative 100. I could make it a little bit simpler between negative 10 and 10, and there it goes. And it's a list 10, so 1, 2, 3, 4, 5, 6, 10. There's 10 items in here. As I reference this for insertion sort, I will be identifying the first item as index 0, as we normally would in computer science, and erase. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's go over insertion sort real quick before we start. So let's say you have this list. Let's make it a little bit shorter. Let's make it 5. 5 and 0 being the lower bound. So the way this works is you start at the beginning and you check if you start the first one and you check if this element is less than the beginning part. And the way I learned this is if you think of like a wall, and you check if the element to the right of the wall is less than the element to the left of the wall in order. So first you check is 3 less than 0 and say no. Okay, let's move on. So you move the wall over 1 and it goes 8 less than 0, no. Is 8 less than 3, no. So then you move on because then you hit the wall, move the wall over. And you have 3 on the right. Is 3 less than 0? No. Is 3 less than 3? No. Is 3 less than 8? And you say yes, and then you swap them. So what happens here is you're basically finding out where the next element belongs. The element on the right belongs in the list on the left. So right now the list on the left is just 1. So if it's less than 0, you just swap them. Over here, right now it's all in order, and you don't swap until it's right here. Then it comes 8. Then we go move the wall. Is 8 less than 8? No. And we move the wall again. And this is our sorted array or list. It makes more sense if they're in more random order. Let's do it again. Let's try this one. So first iteration is the number to the right of the wall less than the number to the left. So is 1 less than 7? Yes. So swap them. 1, 7. Then we move the wall over 1. Is 3 less than 1? No. Is 3 less than 7? Yes. So then we swap them. Three, 7. Then move the wall over. Is 4 less than 1? No. Is 4 less than 3? No. Is 4 less than 7? Yes. And then you swap them. And then you do the same thing. You move the wall over. You check this. All 3 of these. And you go to the next one. Is 5 less than 7? Yes. And then you swap them. And then you have a sorted array. I'm not going to get into the time complexity of it. You'll see as we code how bad it is. So let's get started with the code. So for So I created a for loop, and this is going to go through the whole list, and this is basically me moving the wall. So you see how we start off at after the first element, and we move it through the whole array. So it's after the first element, so you can make that actually 1. So we don't have to start right here, because there's nothing to the left of us. And we'll go to the very end. So this is moving the wall, and I'll comment that. Now, as we move the wall, we're checking if this number is less than the list on the left. So list on the left of the wall would be 1 and 7. Over here, 1, 3, 7. 1, 3, 4, 7. So the list keeps growing every time. So then we'll have another loop inside of it. And we actually want j to be 0, and we want it to go until the wall. So we wanted to check, in this case, if 1's less than 7, and stop, because the wall's right here. So we want to stop where the wall is, which is I. And then we're going to check from the first one up into the wall, so we're going to increase j. So right now, if we try this, console.log, the wall is at I, which is I, and then I'm going to print out like the number just before the wall. So I'm going to print out where the wall is and the number we're checking against. So to do that, we do ran list subscript I. That's going to be like where the wall is and the number we're checking. And then over here, we're going to be doing console.log is this number less than the number we're checking, which is rand list sub j. And we'll see how this goes. Five undefined on line 16. Alright. That's not actual code. Ran list. Oh, length is not a function. Where is that? Okay, there we go. Okay, so the wall is at 1. We're checking number 7. So the wall is just before the first index 0, which is, there's an index 1, which is the second element. So we're checking 7 against 8. It's 7 less than 8. In this case, we would be swapping that. Then we move it over, so the wall is now at 2, which is like the third element, 6. And we're going to check 6 less than 8, 6 less than 7. I'm going to move the wall over. I'm going to say, is this 6 over here less than 8, 7, or 6? And you swap them, and so on. So we know that it's working right now. Now I got to actually make the swaps happen. So if rand list sub I is less than rand list sub j. We're going to be swapping them right here. Then we could have let temp equal rand list sub I, rand list sub I equals rand list sub j, rand list sub j equals 10. So what happened right here is you can't swap two variables without deleting one. So if we have a equal to 5, b equal to 10, and we want to swap them, you do a equals b, and then b equals a. If you do this, a is 5 and b is 10. Then down here, a becomes 10 and b is still 10. So b equals a is this 10 equals b, which is already true. So you're losing the value of a right here. So what you have to do is create a temp variable and go temp b equals a, or b equals temp. Then we could rewrite b, and then a equals temp, which was the original value of b. So, and temp is just a temporary variable. So if we run this, by the time we're done, we should have a sorted list. So we begin with 3, 1, 2, 2, 8, and we end up with 1, 2, 2, 3, 8. So it becomes sorted, and let's kind of go through it. So the wall is at I, or index 1. I'm going to check if 1 is less than 3. So I'm going to, let's see here. I'm going to combine this so it's these two are on the same line. That way it's a little bit easier to read. Actually, never mind. Yeah. Okay, so let's just read it as is. So the wall is at index 1. We're going to check number 1. Is 1 less than 3? Yes, so we're going to swap them. Now the wall is at 2. So we're going to check number index 2, which is the third element, which is 2. We're going to check that number. Is 2 less than 1? No. Is 2 less than 3? Yes, so we're going to swap them. In this case, you can see that as we go through this, these are in order. So you see, instead of 3 being checked first, we're checking 1, then 3. And then we swap them, and then we have 1, 2, and 3. Then we swap them, we have 1, 2, 2, 3. So you can see that as we're organizing them, the order in which we're checking them changes because we're sorting it as we go along. And that's basically insertion sort. It's pretty easy. Hopefully printing this out helps. I know when I learned this, it wasn't, I wasn't given a, like, we walked through it, but we didn't walk through it in the algorithm. And to me, doing that makes it a whole lot easier because you see where things are being consoled out. So right here we know the wall is at I, checking number this. That only happens when we move the wall, and that only happens after we go through that for loop, and then we go to the outer for loop, and then we print that out, and you can see it more visually. So it might be a little bit better organization. So that's insertion sort. You can tell that we have 2 loops right here, and I guess the index is n squared because you have n times doing the outer loop, n times doing the inner loop, so n times n becomes n squared. So hopefully you enjoyed this.